I know where there's some, right here in the hall, clerk.
No, Molly, I have no.
At this point, I have all of the Bakelite housed capacitors replaced, except for this block of 4 right here. These guys right here, and they're on the schematic as 20B, for example. I think they're all capacitor at 20. Yeah, there's 20A, 20B. Here's a C, and a D is around here somewhere. I'm going to leave those for right now because I would like to get some power into this and find out where we stand. But there's one more thing to do before I can do that. Well, that, and I've been waiting on a tube. Which one was it? Oh, the 78 tube that came with the radio. All of the rest of them tested fine. 78 tube is bad. I had to order one of those. But I want to work on this band switch right now. It's still, I've lubed it, but it's, it's freewheeling all the way around. I don't think it's supposed to do that. It's supposed to have 2 settings. Larry in his channel, Back to the Future Radios, had bigger problems than I have with his band switch on his 66. I think he's working on a Philco 66. But I'm going to pull that out of the chassis. The wires look long enough, except for this Cornell Doublier. I might have to desolder that one, but I can pull it out and take a look. I think there are some detents down in there that might need some lubing. So I'll do that first. Or if there are detents, it might be under there. Oh, as I recall from Larry's video, I think they are under there. Huh. Okay. Shoot. Well, if I remember correctly, he had to pull this. There's a retaining clip right here that has to come out before the shaft will move that way. So if I can find the beginning of it. There it is. All right, let me see if I can get that out without piercing my fingers. Okay, all it took was to shut the camera off. There the retaining clip is. Now the shaft should go back, through. Get wires out of the way. And this wafer should come back toward me. Oh! And the bits fell out. I forgot about that part. I needed to go back and watch Larry's video again, obviously. The bits are these little spring clips that actually provide contact between these plates on the switch. And I managed to drop them all. Wow. Class act. There's the 4th one. Right here. Okay. what I'm looking for is this part of the mechanism is a spring loaded, and I don't know if you can see it, but it has a it has a point right there, and the point is supposed to drop into a detent somewhere. But I'm looking at this switch. Let me move you a little bit. And there's this piece of metal has a bulge on it here, but this one looks like it's broken off or bent. I can't tell. I can't tell whether there should be an equivalent on this side of this thing. Okay. Well, I'm going to go back and watch Larry's video again and see what he says about that detent. The good news is the 4 clips that fell off all go into these 4, so I don't have to figure out where they go. There aren't multiple options. There's just one option. Anyway, I'll go do some research and get back to you. Okay, I reviewed Larry's video, and this is a slightly different switch, of course. The detent works differently. The reason, well, let me talk about how this works. There's a raised bump right here. This raised bump slides over this raised bump right here on the switch. There's a gap in the spring steel on, 180 degrees on the other side right here. And I can see where there used to be a raised piece of metal right here. See if I can zoom in a little bit. Right here, this used to be the detent. It's worn down so that it will slide past this gap. This gap is what's supposed to, this piece of metal is supposed to keep the switch from, doing this, sliding only in those 2 positions like that. But this one is worn down and almost disappeared. What I'm going to do is get a pair of pliers in here, needle nose, and see if I can prop this piece of metal up a little bit and restore some detent. But it's not going to fix, at some point in the distant future, it will come undone again. I'm not sure what else I could do about it. I'm not up to rebuilding something like that. It's a relatively simple piece of metal, I suppose, but not my forte. So what I'll do is see if I can get this detent to stand, this detent pin right here to stand a bit taller. Hold on. Okay, I've encouraged that to stand up a bit more. So we'll see if it's going to help now. Yeah, okay, I can feel it now. So there are the 2. I mean, it won't take much to go past it, but that's how it's supposed to work right there. Yeah, I may work on that a bit more and see if I can get a bit more metal back in place. Okay, that is about as much as I can encourage that to stand up. As I said, it won't stand up for very long. On the other hand, there's no longer a police band to switch to, so That's kind of sad in and of itself, I suppose. Yeah, so it's working, sort of. It's not great, but it's working. All right. It's as good as I'm going to fix it. I know where they are now. I know what it feels like, at least. Now I have to see if I can get these actually, I might clean up. I'll take some deoxit and clean the black tarnish off these pads right here. Those pads are what these guys touch. In fact, I'll clean these up too. Then I'll see if I can figure out how to put them back on. At this point, I have 2 of them in place and the piece of tape started. So hopefully I can just fit the other ones. Put the tape in place and then put this back where it belongs. Okay, that only needs to hold long enough for me to get this in. Okay, now I should be able to remove the tape. And they're all back where they belong. Whew. Some kind of work. So I think at this moment we're okay. And it feels like a 2-position band switch now, so I think we're okay. What I will do is put it back in place, and then we'll go look at the schematic and see what this band switch is actually doing. Okay, what does this band switch do? If you look at the dial of the radio, it has 2 bands. Standard, 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 set all the way around there. And it runs from 500, 450, 450 up through 1500. That's 450, 500 megacycle or kilohertz, kilocycles, up to 1.5 megahertz. The police band, which is this inner dial here, runs from 1.5 megahertz up to 4 megahertz. So the police bands, and there are 2, one there and one there. Aircraft band is here, and amateur radio band is here. So what the radio has to do is, in broadcast band position, it has to receive stations that are between 500 and 150, in essence. And police band, it has to receive stations that are from 150 up to 4 megahertz, 1.5 megahertz to 4 megahertz. And so this is a higher frequency range than the broadcast band. Well, how do you do that? For example, if you owned this Philco radio in 1935 in San Bernardino, California, you'd have listened to the police band at 17.2 kilocycles, which is right about there. And that would have been KGZY, the police station, for two-way traffic on the police radios in 1935. So, as I said, these police bands are long gone. Police frequencies are now often hidden or encoded so that you can't listen to them openly. But in the 30s, you could listen to them, and that's why it had a police band. Now let's see how the radio handled a different set of frequencies for police band. Let's look at the radio at large from right here. Where do I want to say this? Yeah, from right here, we've got the first stage is the RF input, then the detector oscillator, and then from here on out, everything should be at the intermediate frequency of, in the case of this radio, 460 kilohertz. And it is, up through the detector and audio output. So what you've got to change if you want to change the frequency of the radio stations you're receiving from broadcast band to police band is change some coils here. Change some frequencies, both in the RF section, right here, and in the local oscillator section right here. And if you look closely, this switch, this dashed line, indicates where the band switch operates. So if it's shown right now in AM, in broadcast band, and you can see this switch is supposed to be open and this coil operative. This switch is open and all of this coil operative. This switch is open and all of this coil operative, and the switch is open right here, and the capacitor that it's connected to isn't doing anything. If you switch to police band, starting again at the antenna section, if you switch to police band, that switch is closed and this coil is shorted out. The only coil remaining, and the resistor, the coil and the resistor is shorted out. Antenna signals go directly to this small coil here, which get fed into the into this secondary RF coil or RF transformer. Likewise, when you switch to police band, this switch closes, and that shorts out the center section of this two-tap transformer secondary here, so that only this part of the transformer and this part of the transformer are working. Down here, switching to police band adds in a capacitor here to this circuit, so we have two capacitors in parallel, changing the resonant circuit of the oscillator. At the same time, the switch closes here and takes out the middle section of this primary of the oscillator coil, so that now we've changed the fundamental frequency of the detector oscillator upwards, so it's at a higher frequency that will still mix and give us, with the higher frequency will mix with the higher frequencies you're receiving from the police band, and that will get detected, turned into 460 kilohertz intermediate band to go on out the radio. So that's what police band does. The police band, the band switch on this particular radio, it could as easily be shortwave. Shortwave is AM. Works in much the same way. You switch to the shortwave bands, you're changing the local oscillator and the RF sections for the most part, so you can receive different frequencies. So that's what it does. Now what we have to do is figure out if this switch is working. And one way we can do that is by measuring the DC resistance across the secondary of the RF coil right here. If it's easy. Yeah, all we have to do is find capacitor 13, put one end of our ohm meter here, then find pin 5 of the detector oscillator, 6A7, and put our ohm meters there, and then we should, as we move the switch back and forth, we should see the DC resistance across this coil shift back and forth to at the same time we're moving the switch. So let me get hooked up. Okay, I've got one lead of the ohm meter right here, and the other lead on pin 5 of the 6A7 detector oscillator. And we're getting 2.6 ohms. 2.6 ohms is about what we should get when we add up. You can see right here 0.3, 1.6, and 0.5. So 2.5, 2.6 ohms is about right. Now when we switch to police band, we'll be shorting out this center section, so our resistance should drop. And it drops down to 0.7. So our band switch is working. That's being reduced. I'll take a look at this one later, but I presume it's working as well. So we're in good shape with the band switch. Hopefully no one will bother with it much. It's in pretty weakened condition, I think, and won't stand a lot of switching back and forth. But for the moment, it works. All right. That's kind of it for the odds and ends of this radio. I've checked all the resistors, everything that's in here that remains, with the exception of this guy right here. I didn't have this is a 2-watt resistor, I believe, given its size, and I don't have a 2-watt, what is that, 2-watt? 30, I can't see it. Maybe a 3200 ohm resistor, 3.2K. Anyway, I don't have one that size. So I'll have to order one and replace it. I also am not enjoying seeing this pair of resistors just kind of hanging in space. I'd rather have one in between there. So I'll probably order some more 1-watt resistors to go in here as well. But otherwise, this is all done with the exception, as I said, of this capacitor case. I just haven't done it yet. I may or may not do it. I am anxious at this point to get some power on this radio with the tubes in and see if we get voltages and some noise. So that's what we'll do next time. Till then, see ya.